Phase difference and path difference. Here I have two sources of waves, S1 and S2. I've marked the peaks of the waves in red and the troughs of the waves in blue, just for clarity. At the central point between the two waves, you'll see that a peak from S1 meets up with a peak from S2. It's the same distance from S1 to this point as it is from S2 to this point. So we have zero path difference and also zero phase difference. The waves are in phase at this point and will constructively interfere. At this point you see a peak from S2 with the red dot has met up with a trough, the blue dot, from S1. So now the waves are completely out of phase, or 180 degrees out of phase. We'll get destructive interference. You'll see that it is half a wavelength closer to S1 than to S2 at this point. So we have half a wavelength path difference. With half a wavelength path difference we get 180 degrees phase difference. A little bit further up, and again peak from S1 meets peak from S2. The waves are in phase at this point. There is constructive interference. But now we are one whole wavelength closer to S1 than we are to S2. So with one wavelength path difference we have zero phase difference. In general, we find that a whole number of wavelengths path difference gives zero phase difference, and so leads to constructive interference. Whereas an odd number of half wavelengths path difference gives 180 degrees phase difference and leads to destructive interference.